Okay, so today we finally move on to lesson 5.6. So take a look at the problem of the day. It's actually a word problem that deals with using synthetic division and factoring completely. I want you to pause the video and set it up. So today we finally move on to 5.6. It's called Find Rational Zeros. So how is this lesson similar or different from the last lesson? In the last lesson, 5.5, I told you what you needed to divide by. In this lesson, I will not tell you what to divide by. Well, how do you know what to divide by then? That's simple. It's something called the rational zero theorem. So it says if f of x equals anxn plus dot 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 plus a1x plus a0. This piece here is just a polynomial. So remember, this is the term polynomial. If it has integer coefficients, then every rational zero has the following form. All right, so we actually determine a list of possible numbers that'll work. Integer coefficients means that the numbers have to be whole numbers, positive or negative. You can't have any decimals, you can't have any fractions. The formula we're going to use, and you'll see this in example 1, is a plus minus, because it could be the positive or negative version of it, factors of constant. Constant's always a sub 0, the number without the x, over factors of leading coefficient, which would be this one here, on the highest degree. All right, so in order to determine what the possible rational zeros are, we're going to do this in example 1, figure out a fraction. So list the possible rational zeros of f using the rational zero theorem and eliminate duplicates. All right, so we start off with our p, and actually I might type this here. It might look a little bit nicer. So my p, if you look, is factors of my constant. What is my constant here? Negative 6. And factors of leading coefficient, my q. Leading coefficient is the highest degree, the number in front, which is 1. All right. Let's draw a little line here. So now, negative 6, let me add something here for a second. We want my factors. So my factors, negative 6 are what? Now the plus minus takes care of the fact that it's negative, all right? But 6 is what? 1 times 6, 2 times 3. So I like to put them in order, like so. And then my factors of 1 are what? 1 times 1, just 1. Now, let's simplify. Actually, I'm going to write this part out. We're going to have what? Plus, minus 1, because 1 divided by 1 is 1. Plus, minus 2 divided by 1 is 2. Plus, minus 3 divided by 1 is 3. Plus, minus 6 divided by 1 is 6. Now, these are the possible solutions that will work using the rational zero theorem. So you have what? 1, 2, 3, 4. 4 times 2, because don't forget, it's a positive or negative 1. Positive or negative 2. Positive or negative 3. Positive negative 6. And I didn't worry about the negative here because that plus minus in front sort of helped me with that. All right, so you can pause the video and try the next one. So for the next one, my p is 8. It's my constant. And then my q this time is 2. It's not 1. So let's see our different combinations here for this one. All right, and I'll type it here. So 8 is what? 1 times 8, 2 times 4. And then 2 is what? 1 times 2. Now in this case, we're going to have to put all four numbers over 1 and then all four numbers over 2. So let's see what we get here. So we get plus minus 1 plus minus 2 plus minus 4 plus minus 8. That's because I'm taking all 1, 2, 3, 4 over 1. Let's look at our fractions too. I have what? Plus minus 1 over 2 is 1/2. Then let's see, plus minus 2 over 2. Plus minus 4 over 2. And plus minus 8 over 2. So I did everything over 1, then everything over 2. If you look, it says eliminate duplicates. Well, what's 2 divided by 2? Isn't it 1? Well, 1's already there, so let's eliminate that one. 4 divided by 2 is 2. That's already there. Cross that one out. 8 divided by 2 is 4. So actually, you only have what? 1, 2, 4, 8, and then the 1/2 there as well. So you have 1, 2, 3, 4, 5, 10 total answers here. 10 total possibilities. Okay, so looking at the rational zero theorem for possible rational zeros. Well, how do we now apply that to what we've been doing in the last lesson? You know how we did synthetic, and then from synthetic division, we did factoring and solving. Well, now we're going to put everything together. We're going to find actual zeros. So find all real zeros of f of x equals x cubed minus 8x squared plus 11x plus 20. All right, so we're going to first list all our possible rational zeros, just like before. Start this here. Q is 20. Q, 1. So what do we get here? We get 1, 2, 4, 5, 10, and 20. And then down here we just get a 1. Which equals plus minus, all over 1's easy, right? 1. Plus minus 2. Plus minus 4. Plus minus 5. Plus minus 10. Plus minus 20. All right. So now where does that lead us with the next one? We have 1, 2, 3, 4, 5, 6. 6 times 2, 12 possibilities to divide by. So what we do in the second part is just take synthetic division, all right? We have to guess and check what works. We're going to randomly pick a number and try it. Now, I don't know about you. I like to usually start with the lower numbers like 1, positive 1, negative 1, positive 1, 2, negative 2. Now we know our goal from before is the remainder has to be 0. Let's just try negative 1. Take all my coefficients from up here. So we guess and check, pick something from the group. And lo and behold, This doesn't really happen too often for me. I'm actually not looking at the answers or any of the work. But you see that it actually worked. -1 is my number that I want. Now there's going to be two other answers that work as well. But pretty much what you do is you pick something. I try 1, -1, 2, -2 usually. I try to go with the smaller number first. Now what does that translate to? All right, we want a zero remainder. From here, we're going to solve completely. I'm going to actually type it here like we've done before. So we have x plus 1. That comes from the front here, right? And we get what? X squared minus 9x plus 20 equals 0. So what's the new part? Just guessing and checking what will give us a 0 remainder. From here, we continue to factor. Should be what? X minus 4, x minus 5. Signs are the same, they're both negative. And then we just set each equal to 0. So x plus 1 equals 0, x equals -1. If I set -4 equal to 0, I get +4, I get +5. So here are my answers. Now you see how -1 worked, right? But like say you were doing this yourself and you tried 4 first. 4 you see would work. All the work here and here would be different, but we'd all get the same answers in the end. Or maybe you guessed 5 first and it worked. Here, this part and the factoring part can be different. So when I check your work, I got to check for the final answer and make sure it's the same. All right, so let's try another one. I actually want you to, same thing again, I want you to actually pause the video and try it yourself first. Remember, if you get something that doesn't work the first time, usually I use pencil to erase it. Like what I mean by that is back here. If whatever I had here didn't work, I would erase it and redo it. All right, so list of possible rational zeros. Here's what I get. Make sure you, hopefully you've had that, or check your work and fix it if you need to. All right, and why don't you try yourself? Hopefully you're trying this on your own and not just watching me and waiting for me to do the work. But see what else works. I choose out of all these a 2. And don't let it confuse you too. I just realized I didn't put a plus minus in front of all these, but there's 1, 2, 3, 4, 8 possible choices. When I did 2, 2 works, but remember there's 2 other solutions that will work as well. So if you didn't get 2, as long as you get 0 remainder, that's all that's important. You see 2 works because I get a 0 remainder. So once again from here, x minus 2. That comes from the front here. X squared minus 6x minus 7 equals 0. To get 2, 7, and -1. Here's all my 3 zeros. So once again, if you were working on your own, which I hope you were, and you did 7, 7 would work. Then if you tried -1, -1 would work as well. All right, so now I posed what happens to the list of possible zeros when the leading coefficient is not 1. All right, so it says find all real zeros of f of x equals 6x cubed plus 25x squared plus 16x minus 15. In this case, we're going to actually use this graph to help us narrow it down. A list of possible rational zeros. When you pause the video and come up with them, there's actually going to be a lot more of them. 15 is 1, 3, 5, 15. 6 is 1, 2, 3, 6. Look what happens here. I go through all the choices. That is a lot of choices, so make sure you have this. I have 16 possibilities, all right? In addition, times 2, 32 choices. Okay, so as you can see, with the list of possible rational zeros, We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times 2 is 32. Now I know there's a couple duplicates. Like if I wanted to go back, not that it's a big deal here. Let's see if I can write this over it, but like 3/3 is a duplicate. 15/3 is a duplicate. This is 1/2. I think that might be it. This one is 2. So there's some duplicates here, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2 is 24. There are 24 possible choices. Now, I don't know about you, but because that Q is a 6, so it says what happens to the list of possible zeros when the leading coefficient is not 1, it makes your choices a lot bigger. There's more choices to choose from of what might work. So that's where the graph comes into play. If you take a look here, where the graph hits, let's see if I can get this here, where the graph hits 0 along the x-axis here, here and here, are all actual zeros to my graph. And you want to try to look for one that's, if you can help it, not a decimal or fraction. Now be careful here. Let's take a look at what we could see. I'll notice that this one's a decimal or fraction. So is this point. But you see this one is right on the line. Can you guys read that? That's actually -3. So what's the point in the graph? The graph is not meant to scare you or make the problem harder. The graph is there actually to help you limit your choices. So it's telling you all my answers are here. Now granted, you might say, hey, if all the answers are graphed, well, what's the point in having to solve it? Well, can you tell what these decimal or fractions are exactly with how they're matched up? It's hard to approximate it. So that's why we still have to solve. So do synthetic division. Bring the 6 down. -18. We get 7. -21. And get 0. So there's my 0 remainder. All right, and let's type it out. I get, the first one was x plus 3. Remember, it's the opposite sign here. X squared, or excuse me, it should be 6x squared plus 7x minus 5 equals 0. Then think about what we should do to factor. You should get 3x plus 5, then 2x minus 1. When we solve, be careful. This is a two-step equation. So we get what? -3 from here. Be careful with this one. We want to move the 5 over as -5, but don't forget we have to divide by the 3 as well. Be very, very careful. If it helps, or if this confuses you, rewrite it out. Here we move the -1 over as a +1. We have to divide by 2. So here's our final solutions. Now let's take a look at one last time here. Here's -3 right here. This is -5/3 because that's what -1 2/3, which is about right. And 1/2 is here. So you see all the points there, but when you have a fraction or decimal, it's hard to approximate it. You want to try to find the one that's the easiest to see to use as your possible rational zero. All right, so that's it for today. No, actually, I think I did this again. So this is not assignment 12, it's assignment 14. So what I'd like you guys to do for homework is to do numbers 1 and 3 on assignment 14. We will pick up with the rest of the problems tomorrow.